Hi, my name is Ann Thomas, and I am in the UNC class of 2023. I'm from Davidson, North Carolina, and I'm a biology major with minors in chemistry and history. I really want to be a peer mentor because of my love of teaching, which I believe stemmed from me tutoring my teammates in Algebra 1 in high school. Since then, I've had the opportunity to join an organization on campus called Girls Engineering Change, where we go to the local Chapel Hill Community Center and teach middle school girls through experiments about sustainability practices within the field of engineering. Additionally, last fall, I was able to teach a public health seminar to high schoolers across North Carolina through Splash UNC, both of which have been incredibly rewarding and fun experiences that I've been able to have throughout college. I will say though, however, my initial transition to college was not easy, and I really struggled with studying and learning, especially in my STEM courses. And although I didn't realize this at the time, that totally ended up benefiting me as it forced me to really look into different studying techniques. Now I could confidently say that I think I have found what works best for me. Therefore, because of my experiences with both teaching and my own personal struggle with learning, if given the opportunity to be a peer mentor, I'm very confident in my ability to not only help my peers learn the material at hand, but also find and implement study techniques that cater to their own schedule and their own learning style. So let me show you what I got. All right, so the question at hand is asking us to calculate the isoelectric point of the following polypeptide. To begin, it's really important to recognize the charges of each amino acid residue at pH of 1, as this will indicate to us the highest starting charge of the protein as a whole. So then we could work down from there to find the two pKs, which lead to the protein having a net charge of 0. Okay, so off screen, I crossed out all of the amino acid residues that don't have ionizable side chains, as they won't have any additional pK values that will play into the final calculation of the isoelectric point. Whereas I noted the charges of all of the ionizable side chains at a pH of 1. In this instance, it's really important to remember to take into account the N and C terminus, as the N terminus has a pKa of 9 and the C has a pKa of about 2, both of which will play into the final calculation of the PI. Additionally, it's really important to know how to figure out the initial charges of all of these ionizable side chains at a pKa of about 1. And so I had a friend teach me this mnemonic to remember them. Additionally, so it says, basically, his lost kid always returned, which tells us that H, R, and K are basic and have an initial charge of +1, whereas as Peter digested the glue, his stomach became acidic, which tells us that aspartic acid and glutamate are acidic, so they have an initial charge of 0. Based on all of these initial charges at a pH of 1, we know that the initial charge of the polypeptide is +3. Alrighty, since we knew that the polypeptide had an initial charge of 3, we were able to work backwards from the +3 down to the net charge of 0 at the Zwitter ion, where the PI could then be calculated. These pK values were just found from the polypeptide itself and all of the ionizable side chains. We work in ascending order from the smaller values to the higher values, as if pKa or pH itself was increasing and the polypeptide was losing ions. With this, we see that in order to get a net charge of 0, it's between the pKs of 9 and 10. So in order to find the PI, we use this equation, 1/2 pKa1 plus pKa2 equals the PI. So in this case, the PI of the following polypeptide is 9.5.